Morning, students. Please switch on your camera. Please switch off your camera. Good morning, sir. Good morning, sir.
Good morning, everyone. Please switch off your camera. Which means we can begin. This is a cargo work session, as I put up on the chat box. And also, please remember, a second session is also there in the afternoon. I think about 15:45. That will be also cargo work as per the timetable. So no confusions. This will be cargo work, and then afternoon also will be continued with cargo work. We will pick up the thread from where we finish here to continue in the afternoon as well. Okay, so we have talked about damages on bulk carrier, but what was remaining was a topic which says where can it be located? The damages, where can they be located? Kindly confirm two things. Number one, I think I'm audible, but you confirm that I'm audible, and secondly, shared screen is visible.
Yes, sir, all good.
Okay, very nice, thank you. So regarding this one, identification of locations where damages could occur for any reason, stresses, improper loading, discharging, etc. on bulk carriers, the locations which is mentioned in the syllabus, those are the ones which you are going to see. But please remember that for this purpose, this has been already in force, which is resolution A.866 bracket 20, this one talking about a guidance by IMO resolution. You are aware A dot means IMO resolution. This has been promulgated already in force, right? This is a guidance given to both ship and terminal who are inspecting as external authorities to look for damages on bulk carriers. So obviously the introduction says that safety is important, that all we have already discussed, you are well aware. Bulk carriers are susceptible to corrosion or damages due to corrosion. They are susceptible, obviously, like any other ship, more so because bulk carriers involve different types of cargoes which may have different reactivity with the hatch cover, sorry, not hatch cover, hatch sides, etc. So they are susceptible, which means they are always prone to any damages of due to corrosion, improper loading, stresses, etc. So this resolution was passed to give some guidance to shipboard personnel and external authorities, terminal personnel who are coming for inspection. You, of course, as chief officer, are involved as shipboard officer to make a careful assessment of any damages caused on the bulk carrier you're working on. Obviously, the responsibility of maintaining the vessel seaworthy and cargo worthy rests with the owner. But you are the owner's representative, so you will carry out this job on his behalf. Uh, just to break away from the topic in a minute, can you tell me who is responsible for, as an external authority, who is responsible for maintaining seaworthiness or the vessel's, correct disposition?
Class.
Okay, class. Okay. You mean to say class is accountable if the vessel is not seaworthy? Are they the people who will maintain it seaworthy?
They will certify that.
Right, right, right. They will certify. But are they responsible and accountable to maintain seaworthiness?
No,
Kindly
sir.
mute.
Some
Kind,
people
Kanji,
on.
there's a lot of background noise. Can everybody mute themselves, please? Ravi Nara, Ravi Nara, kindly mute yourself.
Like,
Okay, I've tried it. I think it will work. We need to keep ourselves muted. You are aware of this already. We are reaching the end of the course almost. That is well known. Okay, so somebody was interacting correctly, but my further query is class accountable for maintaining seaworthiness? Accountable for maintaining seaworthiness.
ship crew, sir, ship crew.
Okay, ship's crew, you say. Okay, but ultimate responsibility will be good. See, class, as somebody has rightly remarked, is the
Owner.
one owner, yes, owner. As rightly remarked by one candidate, class is only going to certify that the ship is seaworthy. But who is going to maintain the seaworthiness and ensure that it remains seaworthy or cargo worthy? Okay, I will tell you basic responsibility as far as the Convention of UNCLOS is concerned. United Nations Convention on Laws of Sea 1982. As far as this convention is concerned, I'm sure you have heard about it. It was part of syllabus in second grade. Maybe you have not read it very extensively, but no problem. Phase 2, you will go through it. The basic responsibility for maintaining this standards of seaworthiness equipment is the responsibility of the flag state. Okay? It is the responsibility of the flag state. But what the flag state does is it appoints a RO, recognized organization, to maintain or not to maintain to a certain list. They may not have the manpower and time to undergo the inspection themselves. So they can appoint an RO, recognized organization, acting on their behalf. Now, these ROs are approved by the flag state, and normally this is a class. That is the background for class. That is how class gets involved. Class does the inspections, surveys, etc. on behalf of the flag state. But the accountability is of the flag state to maintain seaworthiness or cargo worthiness. You get this point? Any other external authority you can recognize who is responsible for maintaining this apart from flag state? RO is just appointed by the flag state. Anybody else who is responsible for this? The job rests with the ship's crew, that we know. But anyone else can intervene and say that this is not seaworthy or anything. Any external authority apart from the flag state. Anji, well, I'll tell you. You see, you have heard of the term port state control. The port state control is actually the second line of defense for ascertaining the seaworthiness, etc., in case the flag state has missed out. It provides a second line of defense, the port state. Both flag state and the port state have a common denominator, that is to eliminate use of substandard ships at sea. Flag state for the international thing, they don't want to have ships flying international, and port state is taking care that no unseaworthy or substandard ship is visiting their port. So in case the flag state has missed out something, port state control will take care, or they will provide a second line of defense. It is actually termed like this, the second line of defense, in case the flag state has missed out something, which is quite possible because of the workload, etc. Quite possible. So in case they miss out, then port state will catch it. Do you get this point? Anyway, the topic of our discussion was to recognize where exactly the locations where you can have damages done on a bulk carrier. Enhanced survey programs are one thing which will, you know, help to establish periodical inspections, but this again rests with the flag state. Planning and performing. We have discussed about it, you are well aware. Severe structural damages may occur to bulk carriers due to loading and unloading operations, which may have not been planned properly. And this can lead to even loss of the ship because it has not been detected, not detected carefully or missed out. This can lead to serious damage or serious fatality. This is the reason why this regulation or this guidance was provided, so that any serious fatality can be avoided. So you should be involved in inspecting cargo holds, hatch covers, ballast tanks with a view of detecting damages and defects. That is your viewpoint. That is how you should approach it, to make sure that nothing goes undetected. For which reason this resolution was passed by IMO. They were very serious about it. They passed this resolution so that nothing gets missed out. At least that is the intention. Accidents do take place, people do miss out some things, but the intention was not to miss out anything and to detect at the earliest, any defect which can lead to accident. So you can have reports, enhanced survey program reports, annual survey reports, renewal survey reports that are on file and are available for the flag state administration or PSC to ascertain that everything is moving according to the program. So the disposition of the bulk carrier or the bulk carrier holds will be like this, that they will have whole structure, topside tanks, double bottom tanks, and maybe wings having ballast facility to be taken in the topside tanks. So anything leading to damage can occur in these places. The damages can occur because cargo shift, bilge hoppers, you know, who are damaged during the collection of cargo on discharge, etc. This is a normal view, if I can say, of the bulk carrier midship. Damages can occur in all these parts which are adjacent to the cargo. Cargo has been loaded here. It is in connection with these places. It may be a single skin or double skin. That is immaterial, but damages do occur. Of course, people who have worked on bulk carriers will be well familiar with this one, general arrangement plan. Nothing new about it. Starting from forward, 1, 2, 3, 4 like this. It is a 7-hole, normally Panamax. Underneath, you can have what is called water ballast tanks, both port and starboard. You may also have, you will have rather, fore-peak tank and after-peak tank. That's the general layout. So moving on, topside tanks, which is over here, these are provided so that you can have ballast water intake here also and to control stresses if arising. Topside tanks, easy to deballast because they are located at a height, so even by gravity they can be pumped out. Just open valves to deballast. That's the advantage. You also have what is called bilge hopper. It is called bilge hopper or bilge hopper tank, which is double bottom tanks in way of bilge hoppers, which is this one, number 2. So you can have damages here also. The strengthening has been done by providing girders, strong frames, or maybe center girders, floors, strong framing in ship's transverse direction, providing double in but double bottom. All of these could be damaged. I'm not saying they do get damaged, but they could be damaged. So these are the places where you will pay special attention when you're doing maybe a PMS routine inspection. You could have a longitudinal framing or a transverse framing. That will depend on the ship owner's requirement or what he has told to be designed. You could have framing done longitudinally or transverse. And to go a step further, you could also have a mixed framing, both longitudinal and transverse. That's a more extensive drawing for showing you different structures, you know, transverse frames, double bottom, girders, center girder here. I don't know if shade screen is visible. Just a minute. Yeah, visible. Should be visible. Please remember, there are chances of damages even not only in the cargo space, which is going to carry cargo and be subjected to stresses, but also in cross deck strips and head side combings. These are all areas identified by IMO where damages can occur. Do make a small note, or if you want, I will capture it somehow. These are the places identified where you can have damages on bulk carrier, which means these are the places you will identify, and having identified, these are the places you will have inspected very carefully. Locations. See, the most important point to be realized is that the ship itself, the ship itself is just a girder, a big girder. That's what you can define the ship as. So girders are subjected to stresses. When subjected to stresses, they can, be deformed to a permanent extent also, because it is a girder, nothing but a girder. On the girder, then you have created space for cargo, you have created space for double bottom, you have created space for carrying ballast. That is okay. But basically, to sum it up, the ship is a girder. So when you talk of girder, it will be subjected to different kind of stresses, leading to damages. Obviously, to do commercial business, it is not possible that you avoid damage at all. To make it zero is not possible. But what you can do is arrest it. Arrest in the sense, identify and then take precaution or any remedial measure to arrest it so that it does not escalate. You cannot prevent damages because it is a girder, it will be subjected to stresses, etc. So you can have different categories for bulk carriers, different categories, cape sizes, Panamax and smaller types, handy size, handy max, which is actually done by the gross tonnage or dead weight. Let us say dead weight. The classification or categorization is done by the dead weight of the vessel of that bulk carrier. Handy size bulk carriers with 5 cargo holds could be called somewhere around 30,000 to 45,000 dead weight. They will be called handy size bulk carriers. Then you can have Panamax. As the name suggests, that is the maximum size of a ship which can cross the Panama Canal. Breadth is about 32.2 meters. These are the ones who can cross Panama Canal, and that is why they're called, in short nickname, Panamax bulkers. Normally, ships of these kinds, Panamax, have 7 cargo holds. Deadweight is around 50,000 to 60,000 tons. When you move on, bigger ships, 50,000, 60,000 ton Panamax over, and you move on, then you can have larger bulk carriers with deadweight about excess of 100,000 tons, which is called Capesizers. Why were they named Capesizers? Any interaction, anything, any thought why they were named Capesizers? They have 9 or more cargo holds. Deadweight is in excess of 100,000 tons, and they have been named as Capesizers. Capesizer bulkers. Any thought why they were called Capesizers? Panamax, we have understood it was called Panamax because this was the largest kind of vessel which could cross Panama Canal. So Panamax over here, handy size because just as the name suggests, it can go in, go out, 5 holes, and handy size. No restrictions on draft, etc. But why was this called Capesizers? So you can have areas identified by this resolution. First, have a look at upper deck area. This is susceptible to longitudinal bending moments. Upper deck area. Cracking of deck plate can occur. Hatchways in way of decks are also susceptible due to torsional stress. You are aware of this cross deck strips? Cross deck strips. These are in way of transverse strips which are connecting port to starboard decks. They are not part of the hold, but they are on the upper deck. It is called cross deck for a very simple reason. It is used to cross the ship transversely from port to starboard and vice versa. This is a diagram which is showing cracks or and the forecastle upper deck checkpoints for cracks deformation on the upper deck. I mean, these are the areas which a chief officer going for a PMS routine check or maybe any external authority can go for identifying. Corrosion of deck machinery foundation, where the deck machinery is mounted, it is called the foundation. This could be having susceptible corrosion, the foundation itself. You could have corrosion on the bulkhead, which is on the forecastle store. This is a door from where you will access it. This is the companion way to lead to forecastle, and you could have cracks on this bulkhead because it is being subjected to this particular bulkhead is being subjected to like the whole shape, but being subjected to pitching. The hatch cover itself could be led to deformation. This can be easily recognized because when you're closing or opening, you will see that the hatch cover is not responding to your order of closing, opening, or maybe wobbling along the travel. Then you easily know that this has been deformed. I think we have done an extensive thing on this one, hatch cover deformation. Pipes, deck plate, crack on the bulwark. Do you recognize this? Can you make out this one? What is it pointing out? This is very important actually. A lot of time you will observe cracks here. Has anybody experienced something like this? Cracks on the bulwark stays. The stays provide strength, but they may be cracked. Cracks on the bulwark stays. Bulwark is this, of course. This is the bulwark. Then there are stays here to strengthen it, but there could be cracks here. One thing mentioned in the resolution is buckling of cross deck. Buckling of cross deck itself. Can you have a thought why buckling of cross deck can take place? Any reason why buckling of cross deck can take place? See, the cross deck is providing transverse stiffening. Because of the movement, the stiffening itself can be the norm. Cross deck is supposed to provide you transverse stiffening. Transverse stiffening. So, due to continuous stress on the cross deck, it can buckle, bleeding to damage which you should be able to identify. So longitudinal system can lead to buckling. Recommended system is the transverse system of strengthening for cross deck. As you can see, this one, this is a longitudinal stiffening, and this is a transverse transverse stiffening. Yeah. Cracking in the upper deck, hatchway corners, right? Hatchway corners. Upper deck plating at hatchway corners is a local point which should be carefully focused on for detecting cracks. Uh, Somebody can recognize this, especially in anybody having sailed on bulk areas. What is this called? This plate. What is it called? Or maybe from ship's construction you can recall. What is this plate called? This one. This plate. What is it called? It is it is actually connecting two hatch sides, this one and this one. And connecting means they are welded here, but this was strengthening. This is what I'm saying. What is it called? Can you recall? Maybe now you can recall. If you read the word, something you can recall. Cassette plate. So what is happening is cassette plate to recognize is something like this. Hatch combing, this side, this is going forward and aft. This is the transverse one, hatch combing. And this connection is called the cassette plate. This itself can be damaged. It is possible that over a period of years you may find a crack on cassette plate itself.
Yes, sir, हो जाता है.
हो जाता है. Okay, very good. I mean, very good in the sense, good for you to recollect. But what we are trying to say is that you must remember to have a careful look at this one. It is possible that the cassette plate itself may, cracken up or may get damaged. Since you say हो जाता है, it is very evident that you might have been involved. You might have been involved in recognizing this on a vessel.
यस सर
Yeah.
मेरे
Okay.
लास्ट शिप पे ही सर इसमें क्रैक था नंबर 7 में.
Okay. Who's saying so? I have not-
ऋषभ लहराज.
ऋषभ. Okay. ऋषभ, tell me, ये जो है कैसेट प्लेट, ये तो आप जानते हैं ऐसी बनती है. इसमें
Yes.
क्रैक कहाँ था? Like
सर यहाँ
this?
सेंटर ये नो सर थोड़ा सा इधर सेंटर से
Like this somewhere.
था कॉर्नर पे ही लेकिन हल्का सा उस पे था मतलब डायगोनल ही नहीं था एग्जैक्टली.
Okay. Okay. Okay.
और वो सर एक्चुअली जैसे कोल और डिस्चार्ज करते थे तो
ग्रैब मारता था.
ग्रैब
Grab
की वजह
मारता.
से
ग्रैब उसको हिट करता था या कर जाता था. हाँ. तो अगर आपको याद होगा ऋषभ, we had done a discussion on this. Damage on bulk carriage due to improper handling of cargo gear. ये उसका पार्ट है. What you are talking, what you are discussing is a part of that. Improper handling of the cargo gear. So this is very much possible. Good of you to remember. So this is another very susceptible area, the cassette plate in the corners of hatch coamings. Please remember, deck line or deck plating is going here. The hatch coaming is leading here. Over here also, at the end, I mean at the bottom part of the hatch coaming, you can have cracks. You should be looking for cracks over here also. ये डायग्राम तो आई डोंट नो आपके सिलेबस में ना हो शायद शिप कंस्ट्रक्शन में, बट डेफिनेटली इट इज पार्ट ऑफ सेकंड मिड सिलेबस. Strengthening of the hedge coaming. It is called that way. Strengthening of the hedge coaming. And you are asked to draw a diagram to show it.
सर एक ही बार कैमरा ऑन करना है या कंटिन्यू रखना है?
कैमरा ये वो आप देखिए व्हाट्सएप पे है शायद, मैडम ने बोला है यू कैन स्विच ऑफ.
ओके सर.
आई थिंक सो. आई थिंक आई सॉ a WhatsApp saying that you can switch off, and in fact she had announced it also. I heard it. I think the attendance has been captured.
यस सर आई मिस्ड दैट.
No problem. Just give me a minute. I wanted to show you one more thing. Okay. So hatchway corners to be carefully inspected, and as one candidate has interacted with us, he had seen it cracked in his last shift. So this must be carefully paid attention to the hatchway corners. This one. Okay, moving further. Deck plate fittings on the upper deck, because they are fittings, these are also or should be examined for any cracks or deformation. They are welded. They are welded to the upper deck, so they might, just shear off or start developing deformation. Deck fittings at the upper deck plating, which means hatch combing side end brackets, bulwark stays, crane posts, foundation, deck houses, etc. Bulwark stays is a very important point for one reason, that if there is a crack on the bulwark stay, then the PSC can give you a deficiency, because that is a non-conformity as far as the continuation of strength is concerned. And when we are talking of bulwark stays for strengthening, this is what I am referring to. This one, this part. This is the stay. This is the bulwark, sorry. This is the bulwark, and this is the stay to strengthen it. This one. So cracks may develop at this point over here, where it is welded to the deck plating.
सर
हाँ जी,
सर एक बात पूछनी थी
हाँ जी, बोलिए।
सर शिवांग दिस साइड
हाँ,
सर
बोलिए।
मेरे को ये जो एलएसए वाले नोट्स हैं वो प्लीज आप वो कर देंगे क्या अपलोड
शिवांग, LSA जो है हमने अभी कवर नहीं किया है।
नहीं
We are
सर
still
एक्चुअल में
discussing.
इस सेशन में एक क्लास है इस वीक में अपनी पास सेफ्टी की
इस सेशन में, अच्छा, some other day.
हाँ ओनली वन क्लास इज देयर ऑफ द
Okay.
सेफ्टी इज देयर
Okay.
एंड द एग्जाम इज मे बी माइट फ्रॉम 2 तो इसलिए हम थोड़ा बहुत पढ़ लेते तो आप वो नोट्स अपलोड कर देते तो
Okay. Okay. I got your point, Shivang. I'll do it. No problem.
ओके
I got
थैंक
your
यू सर
point.
थैंक
I got your point. But definitely, I have made it clear. Afternoon session, my session is also going to pertain to cargo work. ठीक है? But as you say, I identified that you are correct. Maybe you got a point here. I will upload the LSA code which you want. Okay, in the link. Right, I'll do that. But you just give me some time. अभी तो classes continuous है. From here on, I have to move to phase 2. But definitely by the end of the day, I'll do it. Okay. So I think you got the point regarding bulwark stays. This is the bulwark, and this one is the stay. The bulwark stay, and this can easily cracken up over here where it is welded to the deck plating. As I said, this can be a serious concern for the PSC inspection. प्लीज रिमेम्बर हैज कॉमिंग है ये, इसके बाद भी एक स्टे होता है. देयर कुड बी अ स्टे हियर अटैच्ड टू द हैज कॉमिंग फॉर स्ट्रेंथनिंग. दैट कैन आल्सो गिव वे. Okay. This is the point I was talking about. This is the head side coming. You have a stay here. This can loosen out from here. Means it can give way. The welding can give way from here. Right? The session is to continue in the second period. I think it is at 14. I will see. I think it is 15:45 maybe. Just give me time. I will go through the timetable. I will join whenever the next session is slated. Okay. And right now we will stop just to give you time also to arrange the next class, and we will continue in the next session wherever is the timetable. Okay. I'm putting up a chat box because the session is to continue only after lunch. So let's finish on this part. रोज एक ही पौड़ी लगी है
Hello, beta. Good morning, everyone.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Okay, the recording is on, beta. So let's continue with our session. Last lecture, we had started off with the familiarization of the almanac. Did I start off with the almanac, beta? We did the altitude correction.
No, sir.
Okay, so last lecture, what we did was sailings.
No, sir.
Okay, just give me a minute. Okay, I believe we had done the altitude correction, total correction or anything.
Yes, sir. Just we have done.
Okay, so I told you about the total correction of sun, the stars and the planet. I think moon was balance. Is that right?
Yes, sir. Yes, sir.
Okay, all right. Okay, beta. So today what we are going to do is we will see the altitude correction for moon, and then I'll tell you about the chronometer ambiguity, and then we will familiarize ourselves with the daily page of the almanac, what all information is provided to us there. And once that is done, then we are ready to jump into the calculations. So the first of the calculations will be calculation of azimuth and the calculation of amplitude. So I have two sessions with you. One is after lunch. So let's see how much we can cover up in these sessions. So let's start off with the total correction for moon first, and then we move ahead. Before I go ahead, any doubt or queries in your mind? Okay, great. We have a clean slate to proceed ahead. Now, one thing which I want to tell you better before I go into the presentation is that since we have entered into our last month of the course now, if anyone's documentation is pending, please complete that documentation as soon as possible. Otherwise, if you delay your documentation now at this stage, it may lead into delay in the certificate generation. Because till the time we receive all your documents, we cannot confirm your admission. The admission is not confirmed. It is still pending, provisional. So any pending documents, please submit them at the earliest. If the old link is expired, you can request Sergeant Sir to send you a updated link. Okay, so that's one request. Please follow it up. Huh? Okay. Second thing, beta, when at the time of admission you had filled up the admission form, did you fill up a electronic form or a physical form?
Physical, sir.
Physical.
Physical form. Okay.
Physical form, sir.
So did you write it up and scan it and send it?
Yes, sir. Physical form filled it up and uploaded on the same link which we have filled it for the documentation.
Okay, beta, that's great.
मैंने इलेक्ट्रिकल भरा था सर.
Anybody who has not filled up the physical one?
Me sir, Brijesh Kumar. I have done it on my laptop only. The sign is also digital one.
Okay, okay. All right, beta. No problem. It is okay. So you pasted the sign there.
Yes sir.
Okay, it's okay. Not an issue. Okay, so ठीक है बेटा. Please complete any pending documents which you have. Otherwise, the certification is going to get delayed. So with that done, let's now get into the presentation and proceed ahead with our total correction. So just give me a minute. I'll set up the presentation. So I think this was what we did. We did the altitude correction. I told you about all these corrections which are applied. We saw the dip correction table on the first page. We saw the total correction table for the sun and for the stars and planets. So now we are proceeding ahead to revising the total correction for the moon. Let's go. Let's now see the total correction for the moon. Now, moon is the celestial body which is nearest to us, the nearest celestial body. The more closer a celestial body to us, the more complicated its apparent motion becomes. So you will see that all the things associated with moon are slightly more detailed, slightly more complicated as compared to sun or the stars or the planets. The total correction for the moon is given on the last page of the almanac, and it extends to 2 pages. You can see the last page of the almanac now giving the altitude correction for the moon. Now this total correction table is divided into 2 parts. You see the upper part of the table, which gives you the main correction, and you see the lower part of the table, which gives you the HP correction. What is this HP? HP is the horizontal parallax. This is the parallax of the moon when the moon is on the horizon of the observer. So let us see both these tables one by one. Let's zoom into these tables, the upper one and the lower one, and see how these tables are referred to. You can see the upper part of the table now. Now this upper part of the table, which gives us the main correction, is entered from top using the apparent altitude. So apparent altitude has already been obtained by applying index error and dip correction. So you enter into the top part with the apparent altitude. You can see every column gives you a range of 5 degrees of apparent altitude. So from 0 to 4 degree 59 minutes, then 5 degrees to 9:59, then 10 to 14:59, 15 to 19:59, and so on. Depending upon what your apparent altitude is, you enter into one of these columns and you pick up the main correction from this part, upper part of the table. Let's say, for example, your apparent altitude was 3 degrees and 50 minutes. So you will be entering into the first column. You see 0 degrees, then 1 degree, 2 degree, 3 degrees. And then on the side, you can see the minutes, 0 minutes, 10, 20, 30, 40. So for 3 degree 50 minutes, the correction is here, which is 56.1 minutes. So this is how you obtain the main correction. There is a dip correction table given here alongside. But this dip correction table is little shortened. So I would recommend you use the table given on the first page. It is not that this dip correction table is applicable for moon. Dip correction has got nothing to do with the celestial body. Dip correction depends only on the height of eye of the observer, and it is the same for all celestial bodies. So you can refer to the dip correction table given on the first page itself for the moon's dip also. Now let's see the bottom part of the table. You can see the bottom part of the table here. The same column which you entered from top, you go down into the same column for picking up the HP correction in the bottom part. Now, when you enter into the bottom part, you will see 2 columns, 2 sub-columns in every one column of the upper table. One is represented by L and another is represented by U. It stands for the lower limb and the upper limb of the moon. So depending upon whether the altitude is of the lower limb or the altitude is of the upper limb, you will enter into one particular part. And when you come down, you will see on the sides the HP values, horizontal parallax values of the moon are mentioned. So when you come to this part of the table, first you find out whether it is upper limb or lower limb. Let's assume in our particular case, it was a lower limb observation. So you enter into the L part of the column and then you look for the HP of the moon, which was there at the time of the sight. Now, how can we find out the HP of the moon? The HP or the horizontal parallax of the moon is given in the almanac for each and every hour of the year. So once I go to the daily page of the almanac, I will show you the HP value there. So this horizontal parallax is picked up from the daily pages, the date pages of the almanac for the date on which the sight was taken, for the hour for which the sight was taken. So let's assume in this case the HP was 54.3 minutes. So you can see for the lower limb and for a HP of 54.3, the HP correction is 0.7 minutes. So you have obtained the upper correction, which was 56.1 minutes. You have obtained the HP correction, which was 0.7 minutes. Now both these corrections are positive. Both these corrections are positive. They have to be added up. Now once you add up, after that one more thing has to be seen. If it was a lower limb observation, the altitude was of the lower limb, you add these two corrections and you will obtain the true altitude of the moon, or you will obtain the total correction for the moon. But in case if this was the upper limb of the moon, then you have to subtract 30 minutes in the end. You can call it a upper limb correction, and 30 minutes have to be subtracted from the altitude of the upper limb to obtain the true altitude of the body. So to summarize, you get the main correction from the top part of the table. You get the HP correction from the bottom part of the table. Both these corrections are positive. If it is a lower limb observation, apply these two corrections and you will obtain the true altitude. If it is a upper limb observation, after applying these two corrections, you have to subtract 30 minutes, can be considered as a upper limb correction to obtain the true altitude of the body. Now all this which I have explained is mentioned in this part here. You see, 30 minutes is to be subtracted from the altitude of the upper limb. So it is mentioned in this part here. If you have any doubts, you can just read this explanation given here and it will clarify how the table is to be used. So beta, all refreshed? Any doubts anywhere?
No, sir.
Okay, all right, let's proceed ahead then. Let's now move on to the next basic concept, which is the chronometer time ambiguity. Now let's first understand what is this chronometer time ambiguity. The chronometer is a highly accurate clock which is set to the GMT, and whenever you take a sight, you can obtain this GMT from the chronometer. Now the catch here, as you can see in the diagram, The chronometer has a 12-hour dial. The dial of the chronometer is only 12 hours, it's not 24 hour. So it gives you the time in 12-hour format. Now the clocks which we usually have in our homes also give us the 12-hour format time. But there is no ambiguity in those clocks because whatever time it shows, there are two possibilities. It could be AM or it could be PM. Let's say if the clock shows 1000 hours, it could be 10 AM or it could be 10 PM. Now at our home, we don't have any doubt because the position of the sun immediately tells us whether it is AM or PM. But the chronometer does not give you the time of the place where the ship is. The ship could be anywhere on Earth. It is giving you the time of the Greenwich meridian. So there is a possibility it could be 1000 hours or 10 o'clock in the AM, or it could be 2200 hours or 10 o'clock in the PM at Greenwich. So this is the 12-hour ambiguity which we have in the chronometer time. Now, how is this ambiguity resolved? Now, whenever the chronometer time is given to us in the question, with that, a AM PM indication is always given. Whether it is AM on the ship or it is PM on the ship, that indication is always given to you. And it makes sense because whenever you take a site, you will be aware of whether it is AM on board or PM on board. So we use this information to resolve the 12-hour ambiguity. So what we do is we write down both the possibilities for the GMT. The two possibilities, GMT1 and GMT2, are written down. Now we apply the longitude in time to the GMT. Longitude in time. What is this longitude in time? The longitude can be converted into time by dividing it with a factor of 15. So whatever longitude you have, if you divide that longitude by 15, it will give you the longitude in time. Now, from where do we obtain this factor of 15? We know there are total 360 degrees of longitude, and the Earth completes one round in 24 hours. So 360 degrees, one round completed in 24 hours. If you divide 360 by 24, you get this factor of 15. So in 1 hour, the Earth rotates by 15 degrees. So this is the factor which we have. Divide the longitude by 15 and you get the LIT. What is the use of this LIT? LIT can be used to convert GMT to LMT or LMT to GMT. So what do we mean by apply? It can be either added or subtracted. Like in this case, we have the GMT. We can add or subtract the LIT to get the LMT. Now, whether it should be added or it should be subtracted can be easily checked from the idiom. Longitude east, GMT least. Longitude west, GMT best. So depending upon whether your longitude is east or west, you can find out whether the GMT will be least or GMT would be greater. And accordingly, you can use the plus and minus sign. Obviously, when the longitude is west, the GMT has to be best or greater. So you will obviously use a negative sign. And if the longitude is east, that means GMT has to be least. So it means you have to use a plus sign to obtain the LMT. Now, once you apply the LIT, you will have two options of LMT. LMT1 and LMT2. Now these two options which you have obtained, check them with the AM PM indication given in the question. So whatever LMT is correct as per the AM PM indication, one of these LMTs will be in the AMRs, the second one will be in the PMRs. So you find out which is the correct LMT by using the AM PM indication given in the question. Once the correct LMT is obtained, you can go back upwards and you can identify which was the correct GMT. That is the resolution of chronometer ambiguity. Nowadays, the practical use of chronometer has become redundant, and the change is evident in the questions which come in our papers also. Most of the questions, I would say 90% plus questions, are now based on GMT only, and you can straight away pick up the time without bothering about the any ambiguity, 12-hour ambiguity in the time. But it may find way in some of the questions somewhere, and if it comes using this method, you will be able to quickly and easily resolve the chronometer ambiguity and find out the correct GMT time. Now there could be a date ambiguity in some of the celestial navigation questions. What do I mean by date ambiguity? They may give you a particular date in the question, and they may not specify to you whether this date is the local date or the GMT date. There could be two possibilities. It could be local date or it could be the GMT date. If it is specified in the question, then there is no doubt. Whatever they have specified, if they have specified it is the GMT date, you use it as per GMT. If they specify it is the LMT date, you use it as LMT. There is no doubt at all. However, in some of the questions, if it is not specified or not mentioned whether the date given is the local date or the GMT date, what is to be done? So for all these cases, always remember the date given in the question is always the LMT date unless specified otherwise in the question. So whatever date is given to you, you will always consider it as your local date or LMT date unless they have specified exactly that this is GMT. Only in that case it is to be used as GMT. In all other cases, when it is not specified, it is to be used as a LMT date. Now, this is a very important statement and it will help you to resolve any doubt or any ambiguity which you may have in your mind related to the date of the question. Beta, this is also clear, the time as well as the date ambiguity?
Yes, sir.
Okay, all right. Now let's move to the Almanac daily page and familiarize ourselves with the data given on the daily page of the Almanac. Beta, I would recommend you have a Almanac close to you and you can keep on checking all these things which I am telling you one by one. So just let me know once you are ready with the almanacs.
Ready, sir.
Okay, beta. So on every daily page or every day page, there are two pages in the almanac, the left hand side page and the right hand side page. Right now I have opened the top of the left hand side page. Now this one page serves 3 different days. As you can see here, this particular day refers to March 7th, 8th and 9th, Monday, Tuesday and Wednesday. So the data for these 3 dates is given on a single page. Now the first column which you see here gives you the GMT. This is the date, and then you have the hours from 00, 1, 2, 3, 4, 5, 6 up to 24. Then the first column which you have after the date and hour is the Aries column. And you have the GHA of the Aries given to you for every GMT hour. The GHA is given in degrees and minutes. So for any day of the year, for any hour of that day, you can obtain what was the GHA Aries or what will be the GHA Aries at that particular day and hour. Now, if you want to get the GHA for a particular minute also, for a day, hour and minutes, then to this hourly figure, you will have to apply the increment for those many minutes and second. So let us say you want to find out the GHA of Aries for 7th March, 06 hours, 30 minutes and 30 seconds. So up to 06 hours, the value is available here, 255 degrees, 23.4 minutes. For 30 minutes and 30 seconds, you have to go to the increment table. You have to get the increment from there and add that increment to this value. You will get the GHA Aries for any particular day, hour, minute and second in the entire year. The declination of Aries is not given because first point of Aries always remains on the equinoctial. Its declination is always 0. There is no change in its declination. After Aries, you have the 4 planets given to you: Venus, Mars, Jupiter and Saturn. The first figure which is given along with the planet name is its magnitude, the stellar magnitude, which gives us an idea about the brightness of these planets on that particular day. The brightness of the planets can change on a daily basis depending upon what is their location or position in the orbit around the Earth, around the Sun. The Earth and the planet both are revolving around the Sun, and depending upon the positions in their orbits, the brightness or magnitude of planets may vary. Now, under every planet column, you have the GHA and declination given to you for every GMTR. And as mentioned, in case of Aries, if you want it for a particular minute and second, you will have to add the increment. I'll show you the increment table in the coming slides. So you have the GHA and declination mentioned for all the planets. Then you come to the column on the right hand side. This is the column for stars. So you see a list of all the stars mentioned here. This list is given in alphabetical order, and this list gives you 57 selected stars. These are the 57 stars which are most often used for site taking, and they are given here for quick accessibility. Whatever date page you open, you will be able to get the star data from here. What is the data given along with the stars? They have given you the SHA, sidereal R angle, and the declination of each and every star on this page. The names are given in alphabetical order. You can see starting from A and going to B, C, D, and so on. Let's now go to the bottom part of the left-hand side daily page. This is the bottom part. The first column is the Aries column. And at the bottom of this column, you see they have given you the meridian passage of Aries. It's given as 12 hours 53.4 minutes. This meridian passage is given in LMT. This is not GMT. The times given here with the date were the GMT times, but the time given at bottom, the meridian passage time, is in LMT. This is the LMT meridian passage of Aries. Now, under the planet columns, you see 4 columns. These were for 4 planets: Venus, Mars, Jupiter, and Saturn. Under the planet column, you will see the value of V correction and D correction. Victor correction, V correction, and delta correction, D correction. What is this V and D correction for? V correction is used to obtain the GHA of a planet. The hourly GHA is picked up from the daily page. The increment for minute and second is picked up from the increment table. And after applying the hourly figure and the increment, you have to apply the V correction also. The V correction which is given here is for 1 hour, and for whatever minutes you are applying it, you will get the value for this particular V correction in the increment table. I'll show you the increment table after in the next coming slides. So this V correction is for 1 hour. The V correction which is to be used for that particular minute is given in the increment table. Same way, the D correction is applied to the declination. The hourly figure of declination is obtained from the daily page, the date page, and the D correction is applied for any minute and seconds. So this value of D given here is for 1 hour. The value which you require for any particular minute and second will be given in the increment table. So we have the V and D correction given for all the 4 planets. One important thing, if you have observed here, the V correction for Venus, this is the first planet, the first column is for Venus, it could be in the negative range. You see, it is minus 0.6, whereas the V correction for all the other planets is always positive. Then on the right hand side, you see bottom part, right hand side, you have the SHA of all the 4 planets. Venus, Mars, Jupiter, and Saturn, their SHA is mentioned here. And along with the SHA, the meridian passage time of the planets is also mentioned. This is the LMT meridian passage of the planets. LMT meridian passage of all the 4 planets. Let's now go to the right hand side page of the almanac. The right hand side page gives you the data about the sun. The first column is for the sun. You can see the GHA and declination of the sun given for all hours every day. So you can get the hourly figure of GHA as well as declination from the daily page. Then next column, you have the data given for moon. And for the moon, you have the GHA and the declination given for every hour. Now, a difference which you will see for moon is you can see the V correction and D correction given for the moon on an hourly basis. It was not so in the case of planets. For the planets, there was a single V correction and D correction for the entire 3 days. But for the moon, as I told you, moon being closest to us is the most complicated of all. So the V correction and D correction for the moon is given for every hour because the V correction and D correction changes on a hourly basis. You can see the V correction at 00 hours was 7.7 and at 01 hours it became 7.8. Same as with the D correction, 8.3 becomes 8.4, 8.5 and so on. So this is the reason why the V and D correction for moon is given for every hour. And as I told you when we were referring to the total correction table for moon, the HP, horizontal parallax of the moon, is given on the daily page for every hour. So you can see the HP of the moon given here for 00 hours, it is 59.5 minutes. This HP is used for getting the HP correction of the moon from the total correction table. Now we go to the right hand side. In the next column you see we are given twilight times. The twilight times are given to us. We have the nautical twilight and the civil twilight time given here. The twilight times and all the further times. Next you have the sunrise time. Then you have the moonrise time for all the dates, 7th, 8th, 9th, and 1 day extra. One next day is also included here. That is the 10th. It is repeated on the next page also. All these times, whether it is the nautical twilight, civil twilight, sunrise, or moonrise, are in LMTs, local mean times. This is not referred to GMT. These are all LMTs. And they are given against the latitude of the observer. You can see starting from 72 degrees north, for every different latitude, you see the time is different. Let's go to the bottom part of the right hand side page now. We come to the bottom part of the table. This is the first column here. The first column was for the sun. Now at the bottom of this column, you see you have the semi-diameter of the sun given. In this case, it is 16.1 minutes. Now this semi-diameter is applicable for all the 3 days. It remains same, does not change on a daily basis. So 16.1 is the semi-diameter of the moon. May be required if you are doing individual corrections to the altitude. Then you have the D correction to obtain the declination for any minute between the two hourly figures. The D correction is given here. The increment for D correction is obtained from the increment table and applied. Now under the moon's column, you see the semi-diameter of the moon given, 3 values are given. These are the 3 different values for the 3 days. The first one for the topmost day, second one for the middle day, and the last one for the bottom day given in the daily page. So this is because the semi-diameter of the moon keeps on changing on a daily basis. You come to the right hand side. Now right hand side you see the first box for the sun. For the sun they have given you 2 parameters here. One is the equation of time. The equation of time is something related to the true sun and the mean sun, which we will discuss separately. So it is given for 2 times in a day, 00 hours and 12 hours. 11 minutes and 1 seconds, 10 minutes and 54 seconds given for the 7th day. And with the equation of time, you have the meridian passage time. This is the LMT meridian passage of the sun. So in this case, 12:11, next day 12:11, next day it is 12:10. Coming to the right, you have the box for the moon. You have the meridian passage time of the moon given, upper and lower Marpas. Now this upper and lower basically stands for upper meridian passage and lower meridian passage. What is this upper and lower meridian passage? Upper meridian passage is on the observer's meridian. Lower meridian passage is on the observer's inferior meridian. Why is the inferior meridian Marpas time given here? This may be required or used in case the moon becomes circumpolar. So this time is used in circumpolar questions when the moon becomes circumpolar, and we are able to observe it when it is crossing the lower meridian or the inferior meridian of the observer. Next, you have the age of the moon and the phase, how much percentage is visible. So the moon is on 28th day, 29th day, and 00 day, and you can see it is a new moon day. The 9th is a new moon day. The visibility was 4% on 7th, 1% on 8th, and nothing is visible on 9th. So this was the information provided to us in the almanac. Beta, any doubts up to here? Any queries in the mind? सब याद आ गया?
सर ये मून वाला हमारे पास और एज एंड फेज एक बार रिपीट कर देंगे.
Okay, beta. Beta, you see the Marpas time of the moon is given here, upper and lower Marpas. For all practical purposes, you pick up the upper Marpas time. This is the meridian passage on the observer's meridian. So this time which is given is in LMT, so it has to be converted to the GMT time for obtaining any declination or GHA. So this is the Marpas time. And regarding the age and phase of the moon, you see moon has a 29-day cycle from the new moon to the next new moon. So it tells you on which day this the moon is currently in on this particular date. So that is the age of the moon, and the percentage here shows you how much percentage of the moon it will be visible to you on that particular day. So then you see in the picture, it gives you the picture how the moon would appear.
Okay, sir. Thank you.
Okay. Or beta, any other doubt?
No, sir.
Okay. Let's go ahead. Let's now go into the increment table. Go ahead, beta.
So there is a small doubt.
Mm-hmm.
Sir, in exercise 30, we have calculated that in fifth question. It's related to almanac only, sir.
Okay.
Sir, I have calculated SHA, that is 220 degree, 30.5 minutes, and declination, that is 73 degree, 42 minutes.
Okay. For which body, beta?
Sorry. Yeah, fifth question. Fifth question, 30 exercise 30.
This is for which body, beta?
Sir, this is, I have to identify a star.
Okay. All right. ठीक है.
The SHA was 258 degree, 50 decimal 4 minutes, and declination was 16 degree, 50 decimal 7 minutes south.
Okay.
If I see on the daily pages that SHA and declination matches for Sirius, and if I see on page 265, it is some another star, that is Canis Majoris.
Okay.
So
Just a
if
minute,
I
beta. Just give me a minute. I got your doubt. Just give me a minute.
yeah. Phone.
Okay, beta, I'm stuck a little bit in a meeting, beta. So let's hold your question. I will tell you in the next session, beta. I have it after lunch. So this session is almost over now. So we will discuss it in the next question, next session. Huh?
Okay, sir, no problem.
Okay, beta. Okay. See you, beta. Bye bye.
Thank you, sir. Bye-bye.